Ecological pyramids. Everything on the pyramids and web sheet has a brief description, pretty much enough as what you need. The three pyramids are really quite simple. Only the last one is useful. Pyramids of numbers, counting animals at each food level, it's one incredibly difficult job to do. And secondly, it only gives us the rough idea that we seem to see fewer lions than gazelles, and we see fewer gazelles than we see grass. That's about it. If you are able to weigh the animals at each food level, you will discover that no higher level can outweigh the lower level. The sad fact is we leave more poop behind than anything else. So the pyramids of biomass will always decay, and it's proof to us what we see. There are far fewer predators than prey. But weighing an animal is a problem because fat, protein, sugars, they all have different energy levels. So the only way to really do this is to measure it by energy. And this gives us a really solid idea of how the environment is working. Energy is an important concept. You'll need it a lot later on in high school. So I'm going to really drum it into you in grade 9. So by the time you reach grade 11, you feel smarter than your peers and you can say, look, I already learned this. I'm comfy with it. It's measured in joules or calories. Calories is a huge unit, joules are tiny. You eat about 2,000 calories of food a day, that's 10 million joules. It takes 4 joules just to take a thimbleful of water up 1 degree Celsius. When you heat a cup of coffee in the microwave, more than 100,000 joules was poured into that cup. So it's a very tiny measurement. In formulas, there's about 4 to 6 formulas you will learn through high school. Ironically, E equals mc squared, typically put against the nuclear bomb, was the first formula I ever saw in life, and it'll be the last one you study. These other three are used in physics. We used to do this one in grade 9 and 10, but we don't. Any one of you wanted to learn these, I could teach you in an hour, and you'd be ready for grade 11. Otherwise, don't worry about it. The types of energy, there's only so many of them, about 5 or 6. Gravity, energy coming in as light, radiation, radio waves, magnetism, heat, sound, elastic, and chemical. And life is chemical energy. We take radiation from the sun, radiant energy, and we build chemical batteries with it. And what do we do with this energy? Well, we grow, we move, we heat up, we run around, we dump it out as waste, we store it on our body progressively more as we age, unfortunately. And it's only the stored energy that can be eaten by a predator. If a lion, God forbid, ate you one day, it only gets the meal that's currently in your stomach, not every meal you ever ate, or the lion would explode in size all of a sudden, and it doesn't. If we look at the animals that have been studied, the vast majority of animals, this is 90% of this woman's energy, 10% was on her body, and the rest got soaked up, keeping her alive, moving, keeping her warm, growing, having babies. And if we look at a little tiny little mouse, poor little mouse, out of the 90% of energy that it burns off every day, more than half of it is being used just to keep the little tiny guy warm. Oddly enough, penguins don't really care, and they use very little energy to keep themselves warm because of that layer of blubber. So how much energy moves on up the food chain? Well, it turns out there's two grand distinctions, plants and animals. Let's look at this plant. How much of the incoming sunlight does the plant actually keep and how much it's reflecting? Look at the plant, look at the earth. What color would the plant be if it absorbed all the sunlight? What color would it be if it reflected all the sunlight? Can you conclude, is the plant really efficient at collecting sunlight or is it bouncing most of it off? Let's look at it under infrared. Under red light, that's where chlorophyll works. These are a picture of a field and some trees under infrared light. Are these leaves and this stubble throwing the light back or is it soaking it up? Once more, we'll go here. We'll do a little mind experiment, thought experiment. Einstein loved them. They were called Gedanken. Look at the asphalt, look at the grass, look at the tree leaves. What surface is soaking up the light? What surface is kicking it back? Now imagine you're barefoot and you're walking across this grass in July and you walk onto the pavement. Which surface took in energy from the sun? Can you figure out using logic, are plants efficient at collecting sunlight or do they waste it? Turns out plants are unbelievably wasteful. They only take in 1% of the incoming light and kick back the other 99%. Particularly, they have no interest in green, yellow, or orange light. They only absorb mostly blue. They kick back 10% of the blue light, almost half of the violet, almost half of the red. But they really love blue light. This is how much light is bouncing back. So, how do we calculate how much of the incoming energy becomes plant life? Well, 100 joules of sunlight, 1% of that is 1 joule. So if a plant gets 100 joules of sunlight, it can build a 1 joule strawberry. All you have to do is move the decimal over twice. Okay? Animals turn out to be 10% efficient. We're better than plants. We keep 90% of our energy, we throw away 90% and we keep 10% on our bodies. And that ratio is pretty much consistent. It's been studied very thoroughly for like over a century now across all animals, right down to the individual cells in your body. If you swallow 100 joules of strawberry, you only get to use 10 joules of it. The other 90 out the tailpipe. If you were a car, nobody would buy you. You are so horrible with your energy burn. Heck, a car at least is at 30% efficiency. A rocket's at 60 or 70%. And like a Tesla electric car, they're like 90% efficient. We're pathetic in terms of the amount of energy we keep on our bodies. Mostly it's to keep us alive. We're, but we've had to learn to be more efficient because we got to catch our food. Plants don't. So if we put together a pyramid of energy, this is what happens. We start, we lop off 2 zeros on the first level from the sun, and then just lop off a 0 every level afterwards. The math is very simple. Here's another way of looking at it. Each level we go up, we throw away an awful lot of the energy out of our body. Okay? And this pyramid holds a key to one of your assignments. Okay, so if you look at this one, this is giving away an answer on the energy pyramid. Now, what does this imply for nature? Well, think about it now. Why will you never find a forest with 50 rabbits and 100 hawks? Why will you always see more zebras and lions? Why can't you find a food chain 20 levels long? And what is wrong in an alien movie when 1,000 alien monsters live off the odd space explorer that lands like once every 50 years? Hey, if predators can't outnumber prey, why then are 10,000 mosquitoes living on a moose? Does that violate this law I just mentioned? Anyway, that's our lesson on pyramids of energy, biomass, and the useless pyramids of numbers.